Hi guys, Rob Newman here. So I've put this video together. It's my first attempt at videos on YouTube. Now I put this together because 2 weeks ago I bought myself a 3018 CNC off Amazon. Now these things are dirt cheap. So I got mine for £189, straight out of China, took a few days to deliver. Didn't really put it together or even look at it until 2 days ago. So I had some spare time on my hand, I think, at the moment, because of what's going on. A lot of people have got a lot of spare time on their hands, and this is a great little hobby machine. So I thought, do you know what? I've got some time in my shed. I can actually start to make stuff, get outside. The weather's turning good, nice and warm here in England. So I thought, do you know what? I'm going to get out there. I'm going to build this machine. Sat in the box, a little scared to build this originally, but you know what? I opened the box and it came with a manual in English, which, to be honest, is fantastic. I built it. It said it takes about 30 minutes to put together on the website. It didn't. It took me an hour and a half to put everything together, because although the instructions are fine, there's certain directions of things which you really need to look closely at the image at, because the instructions aren't quite there for it. The other thing it was missing, okay, was the wiring diagram. The most important thing, right? You built this frame, but it had like 4 or 5 wires. Fortunately, they were pretty easy. There was an X, Y, and a Z axis wire. So they just went straight from the board on the back of the machine, straight into each axis. So each motor that spins. So that was quite good. Now, my big rookie mistake here, which actually is a bit of an annoyance to me, was I got this disc, right? Now, first of all, laptops don't tend to have many drives anymore. Secondly, if they did, they're slot drives. There's not many of them that you push the button and it comes out. I don't have a PC, but I did manage to get this transferred onto a portable hard drive. So I took that portable hard drive, I installed all the drivers, and bang, straight up. The most important thing was connecting the machine itself. So I used a cable straight into my laptop, and then I was able to control it. So what we used in this was the Gerbil software, GRBL software that came with it, called Candle, their version. Very, very simple to use. Got quite a few buttons that don't seem to really do anything, so that's a bit annoying. And that's the control software. But actually what I needed was some design software as well. So I headed over to www.carveco.com, and they've got a product called Maker. Real simple. It used to actually be ArtCam previously, so it was an Autodesk product, and Delcam before that, but it was ArtCam Express previously. It's now Carveco, it's Maker. It's $15 a month, so English £12, dirt cheap, but it pretty much allows you and enables you to do everything you want to be able to make. So in this video, I've made something what I think is pretty cool and relative to the kind of Easter weekend that's going on. And you'll see how I set up, designed in the software, but actually set up my machine and started to machine a sign. Now, why it took 2 days was actually, I'm trying to find the piece, was because I did a bit of a fail. So, certain things I'm going to go through in a whole series of videos is the learning curve on these machines and with software. Right, so my big mistake, I had 2 tools. Okay, I started with a 3mm tool and then a 1.5mm tool. 1.5mm tool was to just clean up all of the detail where the 3mm wouldn't get to. I properly cocked up here. So you may see a load of random holes just in places. That's because I lost my origin point on the machine. Proper, full-on, easy mistake to make, but that cost me probably about 4 hours worth of machining time, a wasted piece of material, and quite a rubbish finish. So I'm going to show you how I made this sign, how I set up the machine for my first attempt of using one of these machines, and then I'm going to create a whole series of videos of things that go right, things that go wrong, different things I can do in that machine using the Gerbil software, and I'm going to be using Carveco Maker. I'm going to try and put links to where I got software from. I'm just using scrap material at the moment, and any tools I can get my hands on at the moment that will get delivered from Amazon across to me. So everything should be pretty accessible to everybody as well. Maker software from Carveco. They've got a complete fundamentals training course, which is why I recommend this one, because a guy called Leighton, super nice guy, he's created like 24 hours worth of learning to do software. Worth a watch. Take you 3 days to learn the software, but in all honesty, it's so simple in design. But when it comes to tool pathing, that's the bit we're going to spend a bit of time going backwards and forwards with, learning some of the tips, tricks, and how to do things. This is a learning curve for me as well, so there's going to be mistakes along the way. I've got a reasonable understanding of these CNCs, how they work with software, but controller software, all these things, we're going to come across lots of problems. Anyway, let's watch my first attempt at machining this and then the actual proper finished piece that I did just today. So thank you. Let's get on with the video. Okay, so I've got ourselves one of these 13/8 machines. I'm going to stick a block of material somewhere on that machine. I'm going to use these clamps. Okay, these are what come with it. So first thing is, this screws in to the hole just there, so it looks a little bit like that. Next thing is, upside down, pops in just like that. Okay, and that, and then your wing nut goes on top. So you end up with 1, 2, 3, and I've lost my 4th of these. 4. So we've got 4 of these pieces. So how do these work? Right, so the slot part here, just loosen it off, slides into this section here. Okay, now what we do, make sure the material's clamped, hold the bottom, just wing nut, tighten it up quite nicely, turn that round. Okay, just give it a nice tighten right there, nice and solid. Drop one in the other side. You may have to loosen the nuts off on this. Okay, loosen them off a bit. Perfect. And then you may have to screw this piece up and again hold these and tighten it down. And again, you don't have to do these from the corners. You can actually pop them in from the side slots, which are here and here as well. So we're going to do the back corner right here. Again, and over here. Now, this is the bit where it can get a little bit worrying, is because the last thing you want to do is crash that tool into that head. Pretty scary if that happens. You'll break your tool, could go flying everywhere, but it causes a lot of damage. So, give that right on the edge. Kind of tricky when you've got your tool in your way. You could move your tool, make it a bit easier on yourself. But hey, nice and tight. You can even get a screwdriver into the top of these if you need be. Just find the right screwdriver. Give it a little bit of a tighten. Just puts a bit of downward pressure on the bit here. Okay, nice and tight. Give them a little tweak. And that's pretty good. Another alternative that can be used for these, and I've known lots of people over the years use them, is double-sided sticky tape. But obviously that makes your bed sticky, and it can come loose if it's a heavy piece. Some thin bits of material, quite nice, but you can lay strips and strips of double-sided sticky tape down there. But you do have to be very careful with that, as parts can come flying out like this. nice and solid, won't move. Okay, that scares me just a little bit. I'm going to take a look at setting up the tool right now. Okay, first thing I'm going to do is change the tool. It's a nice small tool, that one. It doesn't look like it's going around very straight. It looks like it's bent at some point. Alright, let's go into our software. And let's move the tool. Now you can move things on the controller, but I've got a USB connected, and we're going to move it from within the candle software itself. So let's move. It's coming towards me. I'd say this is where it can cause issues. Look at, I mean, that is very, very close. So we definitely don't want to be cutting that section itself here, because that tool's going to break. Right, so machine needs a little oil. Alright, just going to pop these tools out. So bottom one down here and this one here. Okay, and we're just going to loosen them, holding the tool. Probably click just there. So one more twist and it pops out. Okay, I'm going to stick this one in. 3mm tool. I use this for roughing. Quite nice. Chunks out a reasonable amount of material. For the piece I'm going to cut, this is going to do the job. Right, so actually we can hand tighten that to start with. Long way up. Okay, tight. Don't ever leave it like that. It can shoot out. I have seen these things fly off before and shoot through perspex. Okay, 3018. Let's pop that in there. Okay, right, so now we're going to move over to the software side, because we've got a tool, we've got a material held in place, nice and simple. What we need to do is know the length of that tool right there. So we need to reference that tool to the top of this material. Now this material, slightly curved, bit of wood I found sitting in my shed. So we're going to just jog the machine somewhere. Okay, now some people have automatic tools to set the Z height on here. There's another way to do this. It's been used for many years. Right. You get yourself a scrap bit of paper or anything. Okay. Now what you do is you lower the tool down. Not that low, a little bit high. Oh, I'm on continuous. Right, so let's slow that speed down. Let's go to 1. Let's drop it up a little bit. Okay, so the paper here moves nice and freely. Okay, so we can actually see it sitting above the bed. What we want it to do is just be tight and not move. So we're going to drop our step down, probably to 0.01, and just keep moving until it gets a little bit tight. It's quite tight. Right, so that's roughly at that point there, the top of the block. Okay, it's probably going to be different here because it's curved, so we're going to compensate for that in our design when we actually come to it. But this is just about setting up the height of the tool, the clamps and the material, and changing our tool. Okay, next thing we're going to do, come over to the software and 0 our Z. So there's a button to 0 your Z, changes the work coordinates figure, not the machine coordinates, the work coordinates to 0. Okay, so we know that the top of this block on the machine coordinates is 9 minus 9.579 millimeters, but we've reset to 0 our Z. Okay, for safety we're going to move this up, so we're going to change it, say, to continuous again. Now my feed speed is moving a bit fast for me, that's why it happened to crash down into the Z. So we're going to hire this up, we're going to set our origin. Now by default a machine has an origin, and they're the machine coordinates, so they can be here, here, here and here, or wherever the manufacturers set them. And these happen to be noted for us in the Candle software itself. So the next thing we're going to do is create our own coordinates for this. So this is where the home position of the machine will be for any jobs that I do straight after this, really. Okay, that probably looks about safe. Okay, so in the software I'm going to select 0, X and Y. Now I'm going to write down the reference for sanity. Okay, so my X and my machine coordinate is 5.14.514 and my Y is minus 114.608. Okay, so the reason I've wrote these is if later I lose the coordinates, which happens and can happen, it actually happened to me yesterday, I know it's there. Another option is just to turn on your spindle and just move it down. Cut into the block, so just a small amount at a time, and continuously we're going to go back up on this. Okay, turn our spindle off in the software, and we have our reference point just there in that hole. Might be a bit hard to capture on camera. Okay, we have a reference point here. Next thing to do, load in our job. Right, so everything's set up. Okay, we can load our job in. So, very simple to get going. We're going to file, open, and we're going to use our 3mm area clearance toolpath. And we're going to open that, we're going to take a look at it, see what we get, and then we're just going to send this straight to the machine. So off it goes. So while this is machining, we're going to flip over to CNC Maker software and see how we designed this piece that's now going to be cut. Okay, so here we have CNC Maker as a product. Now, I'm not going to show you step by step how I designed exactly what I've done. I've used a number of vector components and just machined them, as you can see. So we're going to fast forward through this section because it is about 20 minutes long. But you're going to see some importing of vectors, some machining setup, and finally exporting to run on the machine, which is the part that at the end of this you see machining. So we've created our vectors. We're going to move over to creating our toolpaths. We're going to do a few pockets or area clearance. So with a 3mm end mill tool and a 1mm end mill tool. So that will get us the detail that we need. We're going to update our speeds, feeds, set up our material thickness within there, make sure all the settings are correct, and run our area clearance toolpath. Then we're going to set up a profiling toolpath to cut around the edge of the model. But in between each time of doing this, we're going to create a simulation as well. So before we send it to a machine, within CNC Maker, you can create or view a simulation of the piece to see exactly what the model is going to look like when it comes off your machine. So you can see that right here. The next stage is making sure that you send it or save those toolpaths to a machine. So here we're saving out toolpaths one by one because we don't have a tool changer, and we've saved them as G-code arcs, and then we save them and import them into our GRBL software one at a time. And as you can see, we're now back over to our piece that's still doing the area clearance toolpath. We'll skip ahead in a bit and take a look to see what our 1mm end mill tool happens to be doing. So I've sped this section up massively because this 1mm to end mill tool takes quite a bit of time to go. So I've sped this up, I think, by about 20 times the speed that it's actually running. So you can watch that tool go in, finishing off, just going around tidying up. You can see a little hand hoover come in. I've only just got this machine, so I haven't set any sort of extraction on the machine as of yet. Something that I'll probably sort out in the next few coming weeks with that one. So we'll finish this model off, then we'll take a look at the finished pieces. Now the finished pieces, I actually cut the sign itself and cut a series of eggs and popped them out over the Easter weekends, painted them up, cleaned this model up, spray painted the back, skimmed off the top very briefly, stuck it out on the lawn for kids for Easter weekend to have a little bit of a search and hunt around with.